Okay, so here we're going to work on an example where we have in the root of the type a squared plus x squared. So here's our integral. We have 1 over x squared times the root x squared plus 4. All right. So again, the positioning of the root is not important, just the fact that we do have a root so that we're able to apply the identity and essentially eliminate the root. Right, and then usually we'll simplify it up to able to solve the integral using using other techniques. Right, so if it's of this form, right, the a squared plus x squared, that means that x, right away our substitution will be x is 2 tangent theta. That means dx will be 2 secant squared theta d theta. All right, and also that tangent of theta is equal to x over 2, right? And that means here, that's for our triangle more than anything. Here our triangle looks like this, right? Here, 2x and then the square root of 4 plus x squared. Okay. Okay, so now having all of this here, let's go ahead and do our substitution. So when we integrate, 1, x is 2 tangent theta, so when I square that, we get 4 tangent squared theta square root x squared is 4 tangent squared theta plus 4. And then dx, and I'll just write my dx actually. I'll put it up here in the numerator. 2 secant squared theta d theta, right? All of that is dx. Okay, I know it looks like a lot, right? Let's start simplifying so that we have the reduced form, which should be pretty straightforward, or at least more straightforward than our initial integral to solve. So we get 2 secant squared theta. Right, so I'm going to factor out that 4 and take the root of that. So that's times 2 square root of tangent squared theta plus 1. All right. I'm going to factor out. Notice that that factor of 2 reduces. So I'm left with 1/4, right? That 4 is in the denominator. So I'm going to move it outside the integral since it's a constant. So what do we have left with? So we have in the numerator, we have secant squared theta, d theta. And then in our denominator, I'm going to go ahead and plug in that substitution, that secant squared, take the root, so we have secant of theta. And then we have one more factor reduces. So finally here we have what I'm going to be working with here, secant theta over tangent squared theta, d theta. Now when I first look at this, I'm like, well, it almost looks like I can just do this right away, but really nothing really sticks out, right? Because the squared is the tangent, right? If it was secant squared, then I could do a simple u sub, right? But that's not going to work out here. And then secant and tangent are, they're not factors, right? I'm dividing them, so I can't, it's not really the derivative of the secant either. So when nothing really seems to pan out, one option is, let me just change everything to sine and cosine and see what happens there. All right, so if I do that, secant becomes 1 over cosine theta. And 1 over tangent squared is cotangent squared, which is cosine squared theta over sine squared theta. And then, of course, d theta. Okay. All right, and then I'll reduce here. We have cosine of theta in the numerator over sine squared theta in the denominator, d theta. Okay, and now I have something here, right? This one is a simple u, and how do I know that? Because if I look in the denominator, I do have a sine squared, but the derivative of sine is cosine of theta, which is right up here. All right, so it's a simple power rule where the power is -2. I add 1, I get -1, so we get -1/4, and now I get 1 over sine of theta. All right, let me because the derivative is cosine theta d theta. And again, don't forget your plus c. So we get negative 1/4 times cosecant theta plus c, applying our definition of the reciprocal of the sine. All right, and again, right, once we're here, we're not done yet. We're almost done. We're one last step away from here is that change the theta, convert it to x, right? There should be no more thetas in your final solution. And for that, we look to our triangle, right? Cosecant theta is the hypotenuse over the opposite. So root 4 plus x squared over x. And don't forget the negative. There we go. Okay, and that's how we arrive at our result here.